All right, today we're going to dive into the invisible architecture that pretty much powers our entire modern world, relational databases. I mean, from your bank account to your online shopping cart, these systems are absolutely everywhere. So let's break down how they actually work.
Well, the secret, it isn't magic. It's actually a brilliant system for organizing information that's been the backbone of technology for decades. And the answer is something called a relational database.
At its core, a relational database doesn't just store data, it organizes it with incredible precision. So instead of a bunch of messy, scattered files, just picture these clean, logical tables that can all connect to one another. This model, which was actually developed way back in the 1970s by Edgar Codd, is still the standard for most business applications today.
So how does it all really work? Well, it all starts with the simplest building block imaginable, the table.
This looks like a simple spreadsheet, right? Well, in database lingo, this whole table is called a relation. The columns, like name and email, are called attributes, and each row, well, that's a tuple. It's a really straightforward but incredibly powerful way to organize information about one specific thing, in this case, our customers. But just storing data in one table, that's just the beginning. The real genius of this system is right there in the name, relational. It is all about how these tables connect to each other. Okay, so to connect tables reliably, every single row needs its own unique identifier. This is called the primary key. If we look back at our customers table, that customer ID is the primary key. So 101 will always be Jane Doe, and 102 will always be John Smith, period. That uniqueness is what guarantees all the data stays accurate. Now, let's bring in a second table for orders. It's got its own primary key, order ID, but hey, look at that. It also has a customer ID column, and that is definitely not an accident. And this right here, this is the magic. By putting customer ID in the orders table, we've created that relation between our two tables. In this case, the customer ID is called a foreign key because it links back to the primary key in the other table. So now we can ask the database, hey, what did Jane Doe, customer 101, order? And it just connects the dots for us. We don't have to duplicate her name and email on every single order she ever makes.
So, you might be wondering, how does the database find this information so fast when there could be millions or even billions of rows? Well, that's where the powerful engine underneath comes into play.
It's kind of like a three-step dance. First, you ask a question using a special language called SQL. Second, a super smart component called the query optimizer analyzes your question and figures out the absolute fastest way to get the answer. Then, finally, it uses something called an index. Think of it like the index in the back of a book, to jump directly to the data it needs without having to scan every single row.
Now, this technology isn't just theoretical. It's the foundation for some of the biggest names in software. I bet you've probably heard of some of them, even if you didn't quite know what they did.
First up, we've got MySQL. It is one of the most popular databases in the entire world, especially for web applications. Think about all the websites and online services you use. A huge number of them run on MySQL because it's powerful, it's reliable, and it's completely open source. Next is PostgreSQL, or as a lot of people call it, Postgres. It's another open source powerhouse, but it's really known for being packed with advanced features and for being super strict about following standards. That makes it a top choice for more complex, data-heavy applications.
And in the commercial world, Oracle Database is an absolute giant. It's been around since the late 70s and is famous for its incredible scalability and reliability. That makes it the go-to for huge corporations and financial institutions.
And of course, from Microsoft, we have SQL Server. It's really designed to be the central data hub for other software applications, which makes it a cornerstone for businesses that are built on the Microsoft ecosystem. So, with all these different options out there, why do people keep coming back to the relational model? Well, it's because it's built for situations where accuracy and trust are totally non-negotiable. Relational databases are basically the gold standard for what's called online transaction processing. We're talking banking, e-commerce, order management. They're perfect for any kind of structured business data and for industries that have to meet strict regulations because their structure pretty much guarantees data integrity. And that guarantee comes from a core principle called ACID compliance. It stands for atomicity, consistency, isolation, and durability. In simple terms, this means any transaction, like transferring money, is atomic. It either happens completely or not at all. It leaves the data consistent, so no rules get broken. It's isolated, so two transactions happening at once don't mess each other up. And it's durable, which just means once a transaction is done, it stays done. This whole thing is what prevents data corruption and why we trust these systems with our most critical information.
Now, that doesn't mean they're the solution for everything. When you're dealing with unstructured data like, say, social media posts, or you just need massive scale with more flexibility, a non-relational database might be a better fit. It's really all about choosing the right tool for the job.
And that really brings us to the main takeaway here. Even with all the new technologies popping up, relational databases are still the absolute workhorses of the software world. Their proven ability to handle data with perfect integrity means they're still powering the most critical applications we rely on every single day.
Seriously, think about it. From the moment you buy your morning coffee to the last email you check at night, you are interacting with these things constantly. The answer is probably way more than you think. Thanks for joining this explainer.